Welcome to another Baka here. In this video, I'll be talking quite a lot about the foundry process and why these foundry processes do link to real life um problems like the Intel 10 nanometers or 20 angstrom being cancelled, or the more normie of you lot will likely know the PS5 Pro. I think for those people unaware, yeah, Sony launched the PS5 Pro not in a great state, but I think majority of the price hike is within the PS5 Pro SoC, and hell, hopefully by the end of this video, you will understand why the PS5 Pro has got this price hike, thanks to me explaining to you why the SoC process, manufacturing and design process. And as for the technical side, hopefully I can do something known as explain why potentially Intel has cancelled 20 angstrom and 10 nanometer, formerly known as Intel 10 nanometers. I think, yeah, for the normies, if you're unaware, you probably heard of Intel, but you probably are not aware how right now Intel is in a free-form state where they are just losing money. A lot of their subsidiaries are losing the money, and as a result, their core businesses are now being affected, and basically a lot of Intel subsidiaries like networking, storage, pre-built data centers, pre-built services, Intel's are like, look, we will still do these things, but however, we are not gonna put our Intel badge on it anymore. We're gonna either one, sell it to a third party that has been doing that for a very long time, or two, if no one wants it, we will shut it down and call it quit. And we go, yeah, sorry, that department is quit. We're fired. Everybody's fired because we can't sustain your department anymore because our core Intel products and services is being harmed by your subsidiary that we cannot sustain. So, first of all, time with the manufacturing process of these silicon is the testing R&D testing node phase, where basically that node is tested and they figure out what the wafers for the normies. This is basically what basically the material they should design to basically make those things. So a lot of time we use, a lot of it right now is very common as of this video. We use silicon and many other things that are maybe not known things, and as well you probably heard of like FinFET, EUV. Yeah, they're the manufacturing tools that are used to manufacture products in the silicon industry. So, and as I said, a lot of time they will be testing and be like, hey, can these, silicon, can do this with, FinFET manufacturing or EUV or whatever. This is a lot of time where the testing phase tends to go through, and they tend to cost this is where a lot of majority of the cost of foundry goes, where their R&D, where they have to waste a lot of money, but in the end they are good for the people that are like potentially like, hey, we've burnt a lot of money to get this shit working. You better get it working. If it's not, it's going to become a lot of problem, which I think Intel 20 angstrom or 10 nanometers had a lot of problems during the testing phase. Which then the next phase of this would be the validation, which means, cool, okay, the R&D is over. Let's validate our research and development to see, okay, time to see if our documentation works. It's how time to test the actual product that we're going to make at a very small scale. A lot of time, a lot of this is like one product and it's only sold internally used. So like if we were to take Intel, they'd probably only be like, oh, were test nanometer, they probably only had like one product and one OEM's like, hey, we made this weird validation product. It doesn't really fit anywhere in the market, but would you want it? That's what a lot of the if you see a lot of small volume stuff, a lot of it that cost a lot of money, that's where a lot of your that's where your the way you manufacture that product is probably where, especially in the silicon industry, probably within like the validation product, they didn't really. And basically, good luck getting your hold on these products. If you're a regular consumer, as a lot of time, as I said, it is a lot of time internal and very, very exclusive. And you need to be very, very in the know how to get access to these validation products. Which then tests the next stage of manufacturing, which is high risk production. As it said, this is when it's like the R&D fully stopped and the multiple large volumes start ramping. So this is a lot of time. Okay, we're no longer small volume hand manufacturing it. We're now using machinery, mass producing them, making them in thousands and millions. And a lot of time, again, there is a bit of risk. As I said, it's a high risk production. A lot of time, it is only, again, exclusive to one customers. And a lot of time, it will be that high risk production will be custom tailored to that one customer that is willing to take this high risk production risk. And this is also this is also the first time where mass production is tested. So like a lot of lesson is learned via the production end. They'll be like, hey, here's what we kind of screwed up in mass production scale that we didn't catch the previous steps. We are caught here. Let's fix it. And oh yeah, we may have affected our one exclusive customer. We can probably do something to help them to get around this problem. And yeah, and basically, as I said, that's it for the high risk production. And then the step that probably a lot of manufacturers that are like the latest, greatest, the speediest thing, a lot of the product that you tech product that's like really, really that you see blasted in your face of like newest generation, newest generation, newest generation. A lot of time they are on the manufacturing process known as the bleeding edge production. This is where the production, just like where it's like, okay, we don't need to custom tailor to one customer anymore. We have a standard template we give out to all customers. And again, this tends to be, again, still isn't like you regular Joe or regular customers tend to be. Again, bleeding edge production tends to be only given to the close partnership of that manufacturing. So like, and again, it's still problematic as one. There are still little bit of jankiness within the bleeding edge production. As I said, it's bleeding edge, it's new, it's again more mass volume. It instead of now making 1 million products a day, it's now potentially 10 million products a day. And guess what? Again, as you scale up in the manufacturing, stuff don't always scale linearly. And a lot of time in bleeding edge, a lot of final problem is found and fixed here. And since again, the customers that are in these that have agreement with the manufacturers for this, a lot of time they are aware of the risk of some bleeding edge production, and this is why you sometimes get like weird skews of like, huh, why does this weird skew? It's like maybe a slightly clock speed different or slightly like one core or like something a little bit cut off. It's like why a lot of time is because the product companies like, yeah, we are on this bleeding edge. We have to have these weird skew to ensure that we can sell all the product we made on this bleeding edge production, even though that process may have caught a little bit of problem previous steps again did not catch. The process which a lot of manufactured regular Joe tends to be able to use, company tend to be able to access, is known as the mass production, mass volume manufacturing. This is where a lot of it is cheap and very, very low cost, and the volume is extremely, extremely good, and a lot of it. And that's how you get, like, when you wonder how you get, like, some of your electronic goods at really, really low, cheap prices, a lot of them are on these mature production process. And as a result, since this is matured, a lot of the product is not faulty out of box. So, like, maybe like 1 out of 1,000,000 times the product will be faulty, instead of like previous step where it's like a lot of it guaranteed to have like 1 in 10 chances there's going to be something wrong with that product as a result of the immature, and there's still a bit of troubleshooting among the production scale. And again, this is where majority of the product, especially in the silicon industry, tends to be made. And a lot of your cars and everything tends to be made on these mass mature nodes. However, the next step, it's kind of a thing known as legacy nodes or legacy manufacturing. These are beyond manufacturing mature stages. These things have almost basically guaranteed to be like 99. When you see advertisement of like 999% guarantee something, they are probably doing these legacy manufacturing process where it's basically like, yeah, we can basically know what the heck is going to be going wrong with our product. We can guarantee it, and we know what's going to be behavior of this product. A lot of time, this thing comes with an issue. Or, as I said, it's legacy. Sometimes the manufacturing process may go from cheap to really, really, really expensive. You wonder why some old stuff is extremely expensive to repair or extremely hard to get hold of. That's because the manufacturing process for that product is in legacy mode, and there is no more new replacement product that is being made, or the things that the manufacturing process that is used to produce those products is no longer, there's no replacement machinery. A lot of the machinery part that gets worn down, guess what? It gets worn down. There is no more replacement, and a lot of times they're salvaging other parts from other working machinery, and into a lot of time as the legacy manufacturing process goes on, it costs more and more, and eventually it becomes really, really, really unviable for this to continue production. And a lot of companies tend to want to avoid the problem of, well, it's gone so legacy that it's really not worth it for us. That's why you have a lot of end of service products, or just products that end up not getting any support, is because they're simply not worth it for these companies. And a lot of time, a lot of these legacy nodes are manufacturing processes are community funded, and people doing this as a hobby, and simply no businesses want to take care of it, or the non-profit tends to take these legacy node process. And the ps5 Pro and the Intel 1020 Angstrom and 10, formerly known as 10 nanometers, they all, what property do they share? They all share the bleeding edge manufacturing process. One product, the ps5 Pro, the executives down at Sony is like, yes, we're willing to spend the extra money to try and be on the bleeding edge, and yes, we will be having to mitigate this with the increase of the MSRP to claw back some of the manufacturing risk and cost that comes with being on the bleeding edge. And hopefully, as it gets to mature, hopefully, with this PS5 Pro and the PS5 generation, as it slowly becomes, more closer to mature, really maturity, or even borderline like legacy some nodeness, where some of the manufacturing process that's making the PS5 SoC is becoming. Hopefully, Sony's like, okay, we will start passing on some of the saving that we have and giving it to the consumer. And I just hope I have told you viewers of this channel that yes, the PS5 Pro is using high risk, high cost manufacturing for those SoCs, and they are kind of preparing you, the new Sony kind of wants to prepare you for like, hey, the consoles, we are no longer just gonna be like low risk with our product. We may start to take some high risk products or do some high risk thing, and we hope you customers understand why I have explained to you why Sony is taking this approach with going a little bit more higher risk than using mass production cheap bottom barrel stuff. Hopefully. Meanwhile, Intel 20 angstrom or 10 nanometers, they decided to cancel it because why? We have sank so much money into this process, and however, we could not get this damn thing to maturity. Result, what's the best process? We probably should just cut off our loss and just be like, yeah, we have some, government funding coming to try and mitigate our cost for our core business. Guess what? Well, we might as well use that instead of dumping that money into getting what a 10 nanometers 20 angstrom working. We already have products at our competitor manufacturer. Might as well just ask our manufacturer, the guy that's already making our products in a third party manufacturing, be like, hey, can you also make this new stuff for us? Those manufacturers probably going to be like, yeah, we will, and probably is more cost efficient for Intel to go, yep, we're going to tax write off our internal 10 nanometers 20 angstrom and just use third party 10 nanometers manufacturing, like from TSMC or even Samsung. Yeah, and basically, anyway, that's it for this video. If you like the video, do the typical video, like and subscribe. And if you want to grow this community, share the video. And I'll see you guys in the next video.